Okay, we're going to start talking some more about motion, and we're going to start with kind of a little review of what we just finished up. Now, first thing we're going to talk about is distance and displacement. For both distance and displacement, we're going to use delta x, okay? And they're both going to be measured in meters. Distance, if you remember, is how far, and it is a scalar, okay? Which means there is no direction. Whereas displacement was change in position. How far you are from your starting point, this is a vector, and it has direction. Now, we're going to start talking about speed and velocity. In the English language, we kind of use those interchangeably, but there's actually a distinction between the two. If I was to say what does speed mean, you would say it's how fast something is going. The letter we're going to use for it is v, okay, because it's like velocity, and it's a scalar. And we're not going to worry about what direction you're going. Now, for velocity, we're also going to say that that's how fast you're going. Something with a high velocity is moving fast. We're still going to use the letter v for it, but this is a vector form. Okay, so we're going to have to worry about direction being important. So, doing problem solving with this, we can use the equation for both of them, v. I'm going to put a little line over it. If I put a line over it, that means average speed. Okay? And we have to be a little bit careful when using this equation. If we think about it, if I want to know how fast somebody was going, the easiest way to do it, if they're running down the hall, would be to measure out the distance in the hall, and then time how long it takes them to cover that distance. And if I divide distance divided by time, I would end up with their speed. Okay? But that only tells me the average speed. Okay? It doesn't tell me about the speed anywhere along the line. It could be that he started off really kind of slow, walking, and then he ran for a little bit, and then he walked some more after that. So it doesn't give me any of that detail. Okay, all it tells me is about the average speed. So only for average speed. Okay, it doesn't give me detail about the speed at any particular moment in time. Now the other thing is we're going to use this equation for velocity or speed. Okay, if I do this, delta x over delta t, if I do v as delta x over delta t, and I want this to be speed, which is a scalar, I have to use distance over here, which is a scalar. Okay? Or, it's going to look exactly the same, but if I want this to be velocity, which is a vector, I need this to be displacement, which is a vector. So, there's an example of that on the top of the next page. The car travels 200 miles north in 5 hours, so it's going to go 200 miles this way, and it's going to stop. And then it's going to go back down this way, south, for 300 miles. Okay, the first two parts of this we've done before. It should be pretty straightforward. What is the distance traveled? Distance, that's a scalar. I don't worry about directions. So I have 200 miles plus 300 miles, which is 500 miles. So the delta x, in this case we need distance though. It's going to be 200 plus 300 is 500 miles. Where delta x is going to be displacement. Okay, we are going to say he goes 200 miles north, turns around, goes 300 miles south. How far from the starting point is he? Well, he ends up 100 miles south of the starting point. Now, part C is average speed. I want speed, that's a scalar. I have to use distance, which is a scalar. So it's going to be 500 miles in 11.5 hours. Because I had 5 hours, stopped for a half hour, and then went south 300 miles in 6 hours. So I add those together to get the total time. And I end up with a velocity of an average speed of 43.5 miles per hour. Then for part D, we're asked to find the average velocity. Again, it's the same equation, except for this time, since we want velocity, which is a vector, we want to use displacement. So it's 100 miles south in 11.5 hours. And that's going to give me an average velocity of 8.7 miles per hour south. Okay, my next question. Car is traveling west at 30 meters per second. Use that west there. I'm going to write down what I've been given. So I've been given that the velocity of it is minus 30 meters per second. I'm given a time of 6 seconds. And I'm asked to find the distance. Now you could have maybe done this one in your head, but as the problems get more complicated, it's a good idea to write down what you're given, write down what you're looking for. Now, part A, how far will it travel? So if I start with this equation, I could plug the numbers in right now and then do the algebra, but I'm going to do the algebra first. I'm trying to find delta x, so I want to get that by itself. So I would have to multiply both sides by the delta t, and then the x would be by itself. I have to cross multiply. So delta x is the delta t. Now, I'm going to plug the values in. My average velocity is minus 30 meters per second, and the time is 6 seconds. I did that partly because I wanted to see what happens with the units. I have meters over seconds times seconds. Seconds are canceling, I'm left with meters. I get minus 180 meters. What does the minus mean? It means west. So the question says how far, okay? I could answer that with just 180 because it didn't really talk about direction. Part B, write an equation for its displacement as a function of time. I've kind of done that over here. Delta x is the delta t. Okay? Now, for this particular one, I can put in for the d the minus 30. So delta x is minus 30 delta t. That would be my equation. For any time t now, I can plug that in there and find out what its displacement is. For C, we're going to skip it down.